Hello students, my name is Kumari Neha. I am working at Bharathidhasanar Matriculation Higher Secondary School, Arakkonam, and I hope that you are very good at home. Yes, so today we are going to see the lesson of 8th standard physics, which is the 4th lesson, and the name of the lesson is turning effect of force and pressure. So before going into the chapter, let's see what does this turning effect of force means. So see here children, what's happening here? Both the children are there on seesaw, right? So here you can see that the children are sitting at the corners of the seesaw. When they are sitting at the corner, you will see that the person who is putting more pressure down or more force, they can only come down, right? Same way here, after the end, that is the down ground position. After that, if they put more force, they cannot go down, right? So that is the relation between the force of turning. Okay, now let's see here. For example, first I have taken a screwdriver. So what is this? In this, I am moving it, right? So when I am moving it, after this position, I cannot even press it even more longer, right? So that means at a one fixed position, when you are putting a pressure or a force in one direction, after a certain point, you cannot exceed more pressure. So that particular fixed point is known as pivot point. Okay. Same way here, if you see, the person is coming inside, right? He is opening the door and he is coming inside. So just see here, after when he is coming inside, whenever he is coming, just see once. Now see, he is opening it and there is a fixed point at the door. So after one particular point, he cannot push more. So what he has to do? He has to pull back it and he has to close it. So that's the main concept in turning force. So let's see what does the definition of this means. So the turning effect at a fixed point. What is the fixed point known as? Fixed point is known as a pivot. P-I-V-O-T. Pivot. This particular thing is known as moment. What it is known as? Moment. M-O-M-E-N-T. Okay. So this means that when we are putting a turning effect, that time at a particular point, you cannot put a more pressure because of the fixed point which is present, and that fixed point is known as pivot. This procedure or this form is known as the moment. Okay. Yes. Now let's see here what does the moment or the force depends here. So there are two things where it is depending. So one is the force applied. See children here, the person is pulling, right? The person is putting the force towards him. So that is more important. Second one is perpendicular distance from the pivot. So this is the pivot which is the fixed point, and in this perpendicular direction, even see here, from here if I put pressure, will this change? No, right? So this means that whenever there is perpendicular distance from the pivot, the force which we are applying, it will little bit minimize, right? Yes. Now here see, there is one more thing. Now this is a door, it has to open. Now just imagine if from the distance I am opening it or closing it, it will be easier. But just imagine if I put pressure here, will it easily go? No, right? So that means if the distance between the fixed point and the force applied is larger, the force which you are giving can be reduced. But same way, if the distance is less, then the force which you are applying it will be very high. Okay. Same way, here you can see that from the topward position how the wall will be. Now this is the wall, to this door is connected. Now if I want to open or close the door, I will put pressure on the corner, right? Because the distance here is larger. Same way, if I put pressure here, will it open or close easily? No, right? You try this at home also children. When you are putting the pressure here, that is near the joint, you will see that you cannot put more pressure. But here, even less force you can open or close the door. Now see here children, what is happening? Here you can see that a girl is riding the cycle. When she is riding the cycle, you can see that she is putting the perpendicular force, right? She is putting force down. That means if the wheels are very big, if she is putting less pressure also, because of the higher force or higher diameter, they will move easily. But same example, if the wheels are very small, she has to put more force, more pressure to change it. Okay. So, here we can see that, we can say one thing, that whenever an equal sized pressure or force is applied to a particular direction. So, here what is the direction? It is downward direction, right? It is known as a couple. What it is known as? It is known as a couple. Okay. So, this couple means that when you are turning around or turning the moment, that time you will see that there will be change in the couple and it will be known as torque. Okay. Yes, what is this word? This is the torque, right. Now see here, distance children, what is there in the problem? So in the problem they are saying that there is a hinge of a door which is at the distance of 4 meter. So what is the distance? Distance here is 4 meter, okay, from the point of application of force. That means there is a door. Suppose this is the knob and this is the fixed position. So he is saying that from this distance there is 4 meter, okay. Then after that, if the force applied is 20 Newton, how much force I am putting? If the force is equal to 20 Newton, you need to find what is the moment of force. So moment of force is having a formula which is, you can write it out, moment of force is equal to the force applied in the particular distance. So it will be, which is the force multiplied by D. So here we know what is the F and we know what is the D. So directly we can apply here and the answer will come as, force is how much? Force is 20 multiplied by distance is 4. So the answer will come as 80 and the unit of force is Newton. You will write Newton and for distance it is meter. So you will directly write here meter and this is 80. Okay, it is not 8, it is 80 Newton meter. Okay children? Yes. Now see here children, let us talk about a different thought. So here you can see that there are 2 sponges, right. I have taken 2 blocks, they are similar blocks. For example, if I take a book. Now for example, this is a book. Now below it is the sponge. Now if I take the book and put the pressure like this, you will see that the sponge is going downwards, right. Same way, if I take another sponge and take the book and if I place it like this, you will see that very less pressure has been applied. So this shows that if the area, what is this? If the area of cross section is more, then you will see that the pressure applied will be less. What is less children? Pressure is less, and same way if the area of cross section is less, then the force, the pressure which is applied is more. So this is important thing in this. Okay children? Yes. Now let's see here how to solve the problem in pressure and force, because now we have talked about moment of force, right. Now let's see here what is the problem. So in this problem they are asking a force of 25 Newton. So what is the force children? Force is equal to 25 Newton. Acts on a body of area of cross section at 20 centimeters square. So area is what? Area is 20 centimeter square, and we need to find what is the pressure, and pressure in pascals we need to find. So what is Pascal? So Pascal is the unit of pressure which it's given by the name Pascal. Okay, yes, the force here, then the pressure you can write like formula here, pressure is equal to F by A. So what is F, children? F is 25. And what is this, children? This is in centimeter squares, right? So this centimeter square you will write as it is. So you are writing 20. So when you are doing the dividing, you will see that this you can cut by the 5 table, 5 4s are, 5 5s are, and the final answer will come by 5 by 4. Now they asked in Pascal. So here we will write Pascal as P A. You can furthermore divide this and you can get the numerical value of that, okay. Now let's see what is there in the second problem. So in the second problem they have given what is the magnitude of force. That means they are asking what is the force. So you can write here force is equal to question mark required in newtons. So force you have to tell in Newton. Newton is the unit of force. To produce a pressure of 250 Pascal. What is the pressure, children? Pressure is 250 Pascal on the area of 40 centimeter square. So what is the area, children? Area is equal to 40 centimeter square. Now you have the two values. First, what is the formula you need to write? You write it as P is equal to F by A. Now you know the value of P, you know the value of A, but you don't know what is F. So what you can do is, this A you can shift it over here, and here it is in divide position. So when it's coming here, it will become in multiply position. So you can write, since F is equal to P multiplied by A. So how to do that? What is P, children? P is 250 and area is 40, right? Yes. So how you can multiply? You can multiply with only the whole numbers first. So when you are multiplying it, 4 5s are 20. How much? 4 2s are 8. 8 plus 2, 10. So you got 100 as value, plus there are 2 more zeros, so you will add that 2 zeros, okay. So the answer will come as 1 0 0 and these 2 zeros. So what is this, children? This is force, and force you need to give in what? You have to give it in newtons. So here it will come Newton. So the answer will be 10,000 Newton force to be applied, okay. Now see here, children, there are few examples of showing the pressure. The first example you can see here that camel is running in the desert, right? So how it can run? So the thing is, in the shoe of the camel there is more space. That is, the area of her shoe or his shoe is little bit more, and because of that the pressure which is applied is little less. So that is why he can run fast. Same way, you are seeing the snow skis, right? The people who are running or you are doing a skiing it's known, okay. So skiers, that time you will see that they are having a flat and long waver type. So that are known as skiers, and here you will see that the area is more. That is why the force which is applied on the snow will be little less, and therefore they will not sink in. Same way, bags which have a broader straps. So whenever you are buying a bag and if the strap is very small, it will hurt, right? But same way, if the straps are very broad, the pressure on your shoulders will be less. So this is the example. Now further example is sharp knife. Whenever we are comparing the sharp knife, it is easy to cut the vegetables, right? But if you are taking a knife which is not sharp, it will not be easy to cut, right? Yes. Same way, pins. Now pin, if it is sharp, it will go inside properly, but if it is blunt, then it will not go in, right students? Yes. So in this lesson, we have attached in the description box study material. So study material will look like this, in which all the question and answer will be provided. Later on, there will be only question bank with the questions. Later on, you can see the self-assessment. In the self-assessment, you have to see the question and plus you have to answer. I hope you have enjoyed the session. Be home, be safe and keep on studying. Bye-bye.